Hey guys, today's lesson is going to focus on graphing exponential functions and the transformation on exponential functions. At the end of today's lesson, you should be able to say, I can graph exponential functions and I can describe the transformations on their parent function. You'll know when a transformation has been done on an exponential because it'll be in the form of f of x is equal to a times b to the x minus h plus k, where h is the horizontal shift on the graph. And if you're adding h to x, then that means that the graph has shifted to the left. And if you subtract h from x, then that means that the graph has shifted to the right. K is the vertical shift on the function. And if you're adding k, then that means that the function was shifted up. And if you subtract k from the function, then that means that it was shifted downward. If a, which is the leading coefficient of the function, is negative, then the function is a reflection over the x-axis. If a's absolute value is greater than 1, then it's going to represent a vertical stretch. And if the absolute value of a is in between 0 and 1, it will represent a vertical compression. Moving into the activities, example 1 through 4, the directions say, identify the parent function and then describe the transformations that took place. So if we look at question number 1, we're given the function f of x is equal to 3 to the x plus 5. So letter A says, well, identify the parent function. Can you guess the parent function? And if you guess that the parent function is f of x is equal to 3 to the x power, you're absolutely correct. Part B says, well, then describe the transformation that took place. So if we look at it, well, how did we get from 3 to the x to 3 to the x plus 5? Well, we added 5, okay? And that is our k. So in part B, since k is being added to the expression, then the graph of f of x is actually being shifted upward 5 units. Looking at example number 3, now I know you're probably saying, well, Miss Mann, how'd you go from 1 to 3? Well, I'm just doing the odds and I'm going to leave the evens for you. So looking at example number 3, we have f of x is equal to negative 4/3 raised to the x plus 2 power plus 7. Well, this one's a little interesting because a lot is going on over here. We have the negative out front, we have this plus 2, or this 2 being added to x, and then we have this plus 7 here, okay? So first, let me not forget that part A says, well, first of all, identify the parent function. So see if you could identify the parent function again. And if you said f of x is equal to 4/3 to the x, you're spot on. You got this. And in part B, now we're going to start taking a look at all the different things that happen to 4/3 raised to the x. Well, first there's that negative out front, and we set up top that if a is negative, then that means that the graph is being reflected. So it's a reflect over the x-axis, right? Or x-axis. Then we're adding 2 to our exponent, x, which means that we are actually going to shift to the left 2 units. And we're adding 7, so therefore it's going to go up 7 units, okay? So what I want you to do is I want you to pause the video and I want you to try examples 2 and 4 on your own. All right, so there you go. Look at 2 and 4 and compare your results with what I have here. All right, so example number 5. We are being asked to graph the function and then identify its key characteristics. And by now we should almost be pros at the key characteristics. That means that they're asking us to identify the domain, the range, look at the end behaviors of the graph, where the graph is crossing over the y-axis, and then any asymptotes. And remember, asymptote is our newer term, and that just simply means where's the graph leading to. So the function that we're given is f of x is equal to 2 to the x plus 5. I would suggest that you could just go ahead and put that straight into your calculator, but just to combine that with what we just did with examples 1 through 4, we could see that the parent function would be 2 to the x. And because we're adding 5 to x, that means that we're going to take the graph of 2 to the x and we're going to move it to the left 5 units. Okay, so our ending results should look something similar to that. So what I'm going to do is I'm going to take out my TI-84. Okay, I'm going to turn it on. And in the y equals, I'm going to punch in the function. Then I'm going to access my table. And if I look, as x increases, y increases pretty rapidly, okay? So I'm just going to take down a couple of values of x and y, predominantly ones that I could graph on the table that is given. So on my paper, I'm going to go from -6 to 0 on the x, and then I'll fill in any y values. So what it would look like is have my x, my y, so -6, 0.5, -5, 1, -4, 2, -3, 4, -2, 8, -1, 16. Okay, and I'm going to pretty much stop there. Now, once I have my table, the next thing to do would be what? Exactly, I'm going to plot my points. Okay, so -5, 1. And your graph should look something like that. The key characteristics, I'm looking at the domain. The domain is what? Yes, those are my x values. So if I look at the x values, x can pretty much be anything that it wants. If x wants to be negative, it could be negative. If x wants to be positive, it could be positive. Okay, so that means that my domain is going to go from -infinity to +infinity. My range, however, a little different here, because if I look at my graph never seems to go over here into this region of the coordinate plane, which is the third quadrant, nor does it enter this region as well, which is quadrant 4. So that means that my range is going to go from 0 to +infinity, meaning that there are no negative values for y here. My end behavior, as I track what is happening with the graph, as x is going to +infinity, which means as x is increasing, okay? And on your table, you can look at it as x is increasing, so it's going down this way. What are your y values doing? Well, those guys are also increasing. So f of x is going to go towards +infinity. As x is decreasing, so now we're looking at this direction of our graph. Okay, we could see that the graph is slowly but surely trying to make its way to 0. Our y-intercept, so looking at the graph, we don't see here where it crosses over the y-axis. However, there is a way to find it. What you could do is you could remember that if I want to find the y-intercept, I need to make my x equal to 0. Okay, so I'm going to rewrite this as 2 to the 0 plus 5, which is just 2 to the 5th, which is equal to 32. Okay, so that means that when y is 32, that's where this graph is going to cross over the y-axis. So that would be the point 0, 32. Okay. My asymptote is where the graph seems like it's going to converge, okay? And it's going towards y equals 0, okay? At this time, pause the video, take down anything that you may have missed. You also have the ability now to rewind it and listen to it as many times as you need. The rest of the examples should be done.